You might be hearing the term Docker and virtual machine for some time, and you might already know that these are used to virtualize. The question is, how are they different? This is the topic we are going to discuss today, Docker versus virtual machine. Welcome to Turkish Wiki. Please subscribe to the channel if you like the content and for more videos. Let's start without wasting more time. First, we will talk about the architecture of Docker and virtual machine in a level-wise manner. In VM, we'll be having an infrastructure layer, which can be your PC or a server in the data center. On top of this layer, we'll have an operating system layer, which can be Windows or distribution of Linux or a Mac OS. On top of this layer, we have a layer called hypervisor. This hypervisor allows to run multiple VM on host machine. The VM will share the host server resources like memory, CPU, etc. There are two types of hypervisors are there, type 1 and type 2. We are not going in details about this in this session today. Examples of hypervisors are VMware and Hyper-V. And the next layer is guest OS layer. Consider you have 3 applications and you need to run this application in total isolation mode. For that, you need to spin up 3 VMs with a guest OS, which will then controlled and monitored by the hypervisor. The OS can be same or different based on your needs. On top of this layer, we have a layer with binaries and library files. An example will be the jar file for different type of database connections. In each guest OS, we need these binaries and library files which needs to run the applications. Finally, we have an application layer. So this is the overview of how VM will look like. Now let's talk about Docker. Same as virtual machine, Docker also has the infrastructure and host OS layer. Next layer is Docker daemon, which replaces the hypervisor in VMs. The Docker daemon is a service which runs containers and interacts with them. We will talk about the Docker daemon in another video. The next layer is binaries and library files which needed for the application. As you notice, we don't need a guest OS here. Here, the binaries and library files are built as a package known as Docker image. Typically, these images include the applications as well. Then the Docker daemon dumps these images, which is known as Docker containers. As you can see, the application is still isolated. The difference between the VM and the Docker is the VM virtualizes the system hardware, and in Docker it virtualizes the OS layer. Now let's talk about in terms of the 4 pillars: memory usage, portability, boot up time, and scalability. Consider you have a server which have 100 GB of memory. You created 3 VMs with memory assigned to it as shown in the image. The problem here is that each guest OS uses the same space for say 1 GB for each. That means you are using 3 GB of disk space just for the guest OS layer. Also, each guest OS needs its own CPU and memory resources. There is a lot of waste of happening right here, right? Once these memories are attached to the VM, we won't be able to use this memory for any other purpose, even if the VM have free memory left as shown in the image. If you configure the same applications in Docker, we don't need a guest OS layer, and here itself we will be saving the memory, CPU, and disk space. Also, we allocate the memory to the application layer, and if the application is not using the 100% memory which allotted to it, we can reassign this to the other applications. In effect, the Docker allows us to reuse the memory. Let's move to the second pillar. Consider you have developing an application and you have set up the environment and did some configuration to run your application on your end. Once the deployment is completed, you need to test the application, and you provide the detail to the tester, which includes the environment details and configuration you did. Here, the tester needs to do all these steps again before starts working on the application testing. Probably, this communication between you and tester will be in a test format or over to a phone. What if you missed mention an important point, or if the tester missed to configure one of it? The application won't work the same way it did on your end, right? And this may cause your valuable time as well. When it comes to Docker, we are building the Docker images which have all configuration library files and the application of code itself. We are building it as a package. The tester can use the same Docker image to run the application on their end without worrying about the configuration or the library files needed for the applications. The same way, we can move this code to production environment in no time. That's cool, right? Let's move to the next pillar. As the Docker images are lightweight and does not have its own OS, we can start or stop the Docker container in milliseconds. On the other hand, VM will take up to 1 minute. The next pillar is scalability. This is one of the main selling points of Docker. Compared to the virtual machine, containers scale much more easily. That is because you can create a new container in seconds to increase the capability of running service. Virtual machine take minutes to start, as we said before. Also, as you see in the above description, we can have more number of applications in a host machine compared to the same host which runs the VMs.